Let me maximize the screen. Okay. So why BI is required or just like this? I mean, I'll be just showing this thing with some diagrams as well as some, flow charts as well, so that the things are quite clear. So BI is that application. It's you can see BI business intelligence applications where what we are doing actually for the data engineers, we are collecting all the source data from different source systems. Suppose this is a BI application of a particular shopping mall. The shopping mall is having different outlets in various, various cities or just like this in a particular country. Okay. So we are collecting all the sales data from different sources, and then the data engineers, they're doing lots of transformation in this part. Why we are doing the transformation? It will help with several questions to be answered. What are those questions? You can see over here. Sales in previous quarter, revenue growth in last 5 years, best selling product in each season. Okay. So this kind of question, there are a lot of questions actually. So we cannot directly check the data or we cannot answer those kind of questions directly from the sales data itself. Okay. It's not only for sales data, any kind of, you can see any kind of industry where we are handling the data. Maybe there are insurance company, maybe there are banking industry. Okay. The raw data means whatever data is getting, we are collecting from the raw level itself. So there the data engineer scopes are not starting with the raw data itself. The raw data is been populated, maybe some web process, maybe some in a particular web portal, the data is getting inputted from the customers. The data engineers are not supporting this. Maybe some mainframes developer, maybe some web developers, they are supporting that particular things. But when the data is getting stored in a particular database from those web portal, the scope of data engineers started from that particular point. Okay, they're transforming those data. They're converting those meaningless data to meaningful data, and they're storing the data in data warehouses. Okay, I'll be just telling all those steps one by one in the next slides. And after pushing the data in data warehouses, the another set of team, they are also, you can say, those are data analytics teams. Generally, they used to create charts and graphs in various visualization reports. Okay, so that the decision maker or the business owner can directly check all those parameters related to their business. After that, they need to take decisions. What should be there? What should be the strategy for the very next day? Maybe their sales are not going well for some reason. So they can check that and immediate day, for the immediate day, they need to pay the attention by which they can have a quick improvement on top of their business. Okay. Yeah, the next slide will be helping with that particular understanding. It's called BI cycle, business intelligence cycle. So this is the entire scope of a data engineers. Data engineers are collecting data from OLTP source systems. This is the source systems where we are receiving the raw data. Okay. So by ETL tool, ETL is a kind of tool which can help to process the meaningless source data to meaningful data in data warehouse. Okay, so this is one of the scope of the data engineers. They're processing the data from the source systems to the target system, which is a data warehouse. Okay, again, at the reporting layer, this is also been done by data engineers, but they generally called the visualization team or data analytics team. The reporting team, they are creating charts and graphs on top of those data warehouses. Okay, on top of those meaningful data. And they're presenting those things maybe on dashboards. There are various charts and graphs, and those can be shown on top of a dashboard. Then the decision strategy planners, who is from the business side, they can check those things and they can see what kind of decision they need to take. If the revenue goes fine, they can see that it's fine, no need to do for the very next day's planning. The strategy is good for their side, so nothing to do. They do not do any changes for the very next day. But suppose any loss is there, there is no such growth for previous 5 quarters or just like this, then they will be changing the things. The decision owners, they can changing the strategy. Maybe they are changing their CEOs. Maybe they are putting some more offers on top of some products or just like this. So they're taking those decisions, and the decisions are getting implemented at the source side again. And again, at the very next day, you can see the changes has been reflected in the data warehouse in the reporting graph itself. Okay. So this is called BI cycle. Yeah, tell me. Sorry. You were telling something, Rohit. Okay. I hope it's a noise only. No issue. Okay. So this is called BI cycle, and it's completing the cycle regularly. So we are having source data. We are receiving some new records from the source systems. Those are getting processed, reflecting those changes in the new dashboard. So the daily basis, the data is getting refreshed. Okay, new data are coming from the source systems. Those are refreshed in data warehouse. Again, those are getting refreshed in dashboard. So daily basis, maybe based on the criticality of the business, the ETL jobs are run. Maybe hourly, maybe half hourly, maybe daily. So based on how much critical the business users are, based on, they need to take immediate decisions. Maybe such critical business are also there. Then the data refresh can be done hourly basis or half hourly basis. For the non-critical business, that can be refreshed daily basis. So whatever business, for the entire days of business, whatever new data we receive from the source systems, we are loading those stuffs at the non-business hours through data warehouse as well as reporting stuffs. Okay. Based on the business criticality, based on the business decisions, we need to refresh the data. We can change the refresh frequency of the data. Just give me some second. Okay. One more important thing. So especially the data engineers, the particular companies, um, the third party vendors and all who are working, we generally work in data engineers. Okay. Mainly companies own people are not working in this kind of designing of ETL, designing of reporting tool, even supporting of the ETL tool, supporting of the ETL, reporting directly. The companies people are not working. Companies people generally from the business side itself, they're people, they are doing MBAs and all, and they're supporting this role, the decision strategy planner, because they should be, very much working with the business associates itself. They can be from the same company. Okay. So that their business doesn't have any loss and they can think of their businesses only. Okay. Over here, you can see I have written OLTP. Now, what is OLTP? Along with that OLTP, there is another terminology called OLAP. So, what is OLTP? Those particular terminologies are very, very important, especially for interview purpose, or maybe when you are a bit senior in your data engineers post or just like this. So maybe you can heard of this kind of terminologies. So just to make your concept clear, so I'm presenting all those stuffs. You can remember these things. So that, I mean, it's not very much tough, but the knowledge is functional as well as those are required for any kind of, I mean, business handling as well. Okay. For your project purpose, when you are live in a project, you need to know the business part as well, not only the technical part. You just need to know business part, how the data is flowing from the source to target, the entire integration things you need to know. So that is why I'm mentioning all those terminologies. So just remember those things. This is not very much tough, not very much technical as well. Just remember what are the things. So OLTP means online transaction processing. Online transaction processing systems are the class of systems that can manage, facilitate, support operational or transactional data. So OLTP is nothing but the source systems. Just like in India, if you can see the railway reservation systems. So we are just going to the ticket counter and there booking our ticket. But their systems are having mainframe, the black window over there. So whatever data we are just telling, they are just putting into that systems and they're booking our ticket. So the mainframe is pushing those kind of transactional data into some databases. They're storing the data in them databases. And those kind of source, those are the source databases for the data engineers. Okay. So those kind of source databases, those are storing all kind of transactional information from the users. Okay. So OLTPs is nothing but whatever transaction at the source side with the customer side directly. So those raw data are getting stored into some databases. Those are called OLTP or online transaction processing systems. Okay. For example, I just mentioned banking transaction. So, I mean, we are doing lots of credit or debit related transactions. Those are also getting stored in some databases. We are having some insurance companies. So, whatever premium we are going to give and whatever things are being covered by the insurance company, lots of things. Each of the, I mean, industry, the healthcare industry, the pharmaceutical industry, the banking industry, just I mentioned, the insurance companies, the airlines industries, every industries, whatever raw data they're receiving from the transaction, those are getting stored in OLTP databases. Okay, so that is called online transaction processing system. Here are those examples: banking transaction, sales transaction in a retail store, railway booking and cancellation. All those things are stored in OLTP database. It's nothing but a database. That can be MySQL server, Oracle server, MS SQL server. Okay. So what is, I mean, as per the architecture of the particular project, they need to choose what kind of database they will be putting as OLTP storage. So the another database just I mentioned with OLTP, there is OLAP, that is called Online Analytical Processing Systems. So when we are processed, I mean, we have modified those meaningless data to meaningful data. We are processing those data. We are storing the data in data warehouses. Before proceeding with the reporting part of the data warehouses, the data is called online analytical processing systems. So the data are ready for analytical purpose. Okay, we are ready for the chart and graph preparation. So after cleansing, after transforming the OLTP data, we are processing the data into data warehouse as well as we are making it fit for the reporting layer, reporting purpose. So there we can tell the data as OLAP, online analytical processing systems. It's very large volume of data because in OLTP there are several transactional systems. I mean, the data is coming maybe 2 days data is there, or incremental data loads are there. What is incremental? I'll be telling. But in OLAP, all the data are getting stored in a single systems because those are ready for the reporting purpose. So that is why the data volume is very large in OLAP, and it's good for analysis purpose. So lots of aggregation functions we can impose on top of OLAP systems. We can create charts and graphs on top of OLAP as well. Yeah, anyone is telling anything? I'm just putting you mute. I think it's some background noise from your side. Okay. So this is OLAP. Moving to the next slide. If there is any step point or anything, please tell me. Okay. Okay. So the person, those are supporting the decisions of the companies. I mean, they're checking from the reporting sides and they're taking the decisions. What is the sales, region wise? How did my revenue improve in last 5 years? So this kind of, there are lots of questions you can see. They're checking those questions and they are getting answers from the reporting. That is fine. But based on their answers, they are taking the proper decisions, which is helpful for the company itself. So their company's own people, maybe they are doing the MBAs, they knows business very well. They're directly sitting with the business person or business owner, and they're taking the decisions for the next day strategy. What should be the strategy for the very next step? So those are called decision support system. Okay. So especially they are from companies people, and there are all, that should be always, that particular team is also required for the business to be improved, or a good strategy should be taken from those technical charts and graphs. Well, okay, this is one of the important thing. So how this is the top chart is called OLAP. In the OLAP systems, we are storing the data in this manner. There should be lots of columns available and all. Lots of data should be available. But after that, the data analytics team, they are preparing this kind of charts and graphs so that the decision owners can take the easy decisions by checking all those parameters, their growth. Lots of charts and graphs can be prepared. You can see this is bar chart. There is lots of bar chart. This is pie chart on top of this kind of data. They have prepared this kind of thing. So how the data can be visualized? If we are checking this kind of data over here in tabular format, it's not easy for the business owner or decision maker to take decisions. That is why the visualization teams are there. They're preparing charts and graphs in dashboards on top of this data. And by checking this, the decision owner can take easy decisions on top of data. Any stuck points so far from anyone? Any questions, anything? Any question in your mind? Nothing? Okay. Okay. Now it's a quick flow chart based on what are the things are, how the things are going on, how the things are going to be stored in data warehouses and all. So this is the source transactional data. As I mentioned, there are data entry operators are there, or maybe users are directly putting the information in web, and those are getting stored in some operational data stores. Okay, so this is the source systems for data engineers itself. Okay, so or you can also tell this is the OLTP system. So all the transactions are getting stored in OLTP systems, and the data engineers scopes are starting from this portion only. They're loading those data from OLTP systems to data warehouse, and this particular tool which is putting this, data from this source system to this target system is called ETL tool. What is the full form of ETL and all? We'll be learning those stuffs in the very next day, tomorrow. I'll be focusing the ETL tool. Okay, let me tell. ETL, E means extract. So we are extracting the data from source system, means whatever new data we receive from the source system, maybe today's business hour, whatever I have received the data, I'll be extracting the data. T for transform. We are transforming the data. L for load. We are loading the data in the data warehouse. So that is ETL stands for extract, transform, load. And generally, this kind of process, ETL is a particular tool or particular job, we can say. The particular job will refresh the source data to the target, the non-business hours. Okay. So the ETL tool will run and refresh the data from source to target, the non-business hours. And then the report or the dashboard will be refreshed on top of the new data which arrives in data warehouse. So the report will reflect the current data of the data warehouses, and that should be presented in front of decision owner or manager, anything we can say, so that they can take the decisions. Now I'll be covering something on top of data warehouse. Okay, so data warehouse resides over here, where the meaningful data are getting stored. That is called data warehouses. So data warehouses should be subject oriented. The data should be integrated in nature. It should be time variant. The historical data we should be getting. So we are not removing the historical data. Maybe based on the business choices, we are storing the data for last 12 years or last 15 years or last 20 years or maybe last 50 years, just like the how much the business criticality is, how much the things should be there. So historical data is never erased. I'm just trying to mention over here. So whatever data I received yesterday, I'm not erasing it. I need to store the historical data as well as the current data so that I can check, I can compare. Maybe 10 or 12 years back, there was a COVID-19 kind of situation. How we have handled that time, how we have handled the business, what are the business parameters. Maybe I'm having the same kind of scenarios again. So I need to check the history that time. So that is why data warehouse is storing the data so that we can analyze that time's information and implement the same kind of thing the very next day's business situation or solutions. Data is not volatile. It's non-volatile. Can retrieve the data anytime. Okay. So this is how the architecture looks like. Actually, I just mentioned it's ETL tool, but ETL cannot be done in a single way. Okay. So those are the extraction, means those are the transactional data. There may be several transactional data. Maybe suppose you are working in a banking industry. Okay. Maybe the card banking, maybe for the customers, is having different cards, maybe debit cards, credit cards, all the card related informations we are receiving in a database called Oracle. Maybe the credit related information I'm receiving from a particular database. Maybe it's a Teradata or maybe it's a MySQL database. The other information, all the customer related informations, I'm not receiving in the same database. I'm receiving it in another database. So there are lots of source of transactional data, as I mentioned last slides as well. So transactional data we are receiving small data sets from different databases. Maybe we can also receive the data from flat file, maybe in CSV. Maybe the data volume is not very much for that particular master data. So user can directly give us CSV file or Excel file for some kind of data inputs as well. Maybe we are receiving data through some APIs. Okay. So all those things are called the transactional data. From the data engineer's perspective, those are the source information what we are receiving from the predecessor team or prerequisite team. Okay. So our scope is starting from here only. We should not be checking how that thing is getting populated. That can be populated maybe some web tool or maybe some software, just like this. But data engineer scope should be starting from here. Maybe some Java developers are there who should be taking care of the early part. Maybe mainframe developer, maybe web developer. Lots of different teams are there for supporting this kind of activity. But the data engineers job should be starting from here only. They need the data to be ready in OLTP systems. Then their scope should be starting by running the ETL job. So first of all, we are storing the data in some staging layer. We are not directly pushing the data in data warehouses. Okay. So we are storing the data in staging layer. Staging layer means all different kind of stuffs are getting stored in a single layer. There are no other logics are implemented. Just we are mapping it. We are just pushing all those stuffs from a single staging layer. Okay. After that, when everything is there in staging layer, we are cleaning the data. We are transforming the data. Whatever aggregations we already know what is. We have some of the experience of aggregation. We have done these things, done or completed this kind of stuffs in SQL as well. We have done summation, average, mean, max, these kind of things. Those are aggregation functions. The similar kind of aggregation functions are also available in ETL tool. Okay. So we are performing this kind of operations and storing the data in operational data stores, ODS or data warehouse or data marts, just like this. What is ODS? I'll be quickly coming. But all of this ODS, data warehouse, data marts, their functionalities are same. They're specially used for OLAP analysis. OLAP I already mentioned is for analytical purpose. They're storing the data over here. Okay. And those blue kind of stuffs, you can see blue arrow in each of the cases. Those blue arrows are nothing but the ETL jobs. For each interface, they are loading the data from the source to target. From source to target. Okay. So this is the split version and the entire version. I'm just telling it over here. There is another thing called metadata layer. To assist the data load from source to target, how we are doing these things, we are taking help with some metadata as well. What is metadata or what is the usage of the metadata? I'll be telling these things in later chapters. But just think about it. This metadata is not about any kind of business data. This is the data of kind of the ETL data. So what particular time the ETL should be run? Maybe I'm storing this information in metadata layer. So this is not the business data, but this metadata is the data which can help to run the ETL jobs. What time it should run? What is the latest timestamp, the last date to completed? So what kind of records, how many records it's getting? The data is processed. Today's jobs has processed. So this kind of information is getting stored in metadata layer. Okay. It can be another database as well. This is non-technical. Maybe users do not need this kind of data. This is for our purpose. Okay. Business requires data warehouse data, not metadata. But for the ETL, whoever is supporting ETL, whoever is designing the ETL, they require the metadata. Especially for the technical stuffs, they only require the metadata access. Okay. So what is ODS? I mentioned over here. ODS, ODS data warehouse and data marts. The functionalities are same, but a bit different things are there. Maybe all of the project, they're not using three things in a single project. Maybe in several projects, some projects they're using ODS, some project they're using data warehouse along with data marts. Data warehouse and data marts, it's almost same. I'll be mentioning what are the things, but just I try to mention in a same project, maybe ODS and data warehouse are not there. Some projects are maintaining ODS, some projects are maintaining data warehouses. Okay, so what is ODS? For the critical applications. So what is the source data? They need the same kind of data at the target quickly. So it's kind of real-time data. As I mentioned few times ago that in the non-business hours, we are loading the data from source to target. This is not for non-critical businesses. Okay, there we are not using ODS. But for ODS in operation, in operational data store, is a data store used for analyze near real-time data. Real-time means when the things are happening at the transactional side, at the source side, in the same day, in the same time, we need to process the source to target data. So it's for very critical businesses, and the same thing can be done because of solving the day-to-day problems quickly. Okay, so this is called ODS. There is data mart as well. What is data mart? Data mart is nothing but it's a miniature of data warehouses that supports the requirement for a particular department for business process. So maybe from the architecture they want to segregate data warehouse data with small subject areas. They are splitting the data in various data marts. Okay. Suppose I have just put example. A data mart is a simple form of data warehouse that is focused on a single subject areas. So for for the all sales related data, I'm keeping the things in a data mart. For finance related data, I'm keeping this thing in finance data mart. For marketing related data, I'm putting this thing in marketing related data mart. All those things are nothing but a a particular database. Just like in our demonstration in last classes, we have done SQL. We are completing the SQL part in MySQL databases. So MySQL can be a data mart. I can create separate schemas for each of the data mart. Okay. So this kind of concept should be clear. Those are nothing but a data base itself. Okay. So here is another flowchart diagrams. Over here you can see it's the insurance OLTP systems. So all the property related insurance data I'm pushing to property data mart so that it's good for OLAP analysis. The reports can be created and it can be, only the property department should be having access to these reports. Okay. In the insurance OLTP databases, we should be having automobile related insurance data as well. I'm segregating this thing in another data mart. So automobile data mart. It's OLAP data. So I'm going to prepare the charts and graphs on top of only automobile data mart. And the report said of the automobile department should be accessing this kind of reports. So this kind of thing. This is just a example of data mart. I'm segregating each of the subject areas of the insurance company. Maybe the insurance company is same. It's a single insurance company, but it is having various subject areas. So based on maybe the access, maybe there are some issues with the automobile as well as property team. They should not be checking each one's data. So that is why I'm segregating the data in different data mart. I'm also segregating the reports and charts. Okay, maybe for security purpose, maybe if as per the company policies, whatever the things are there, the this is the reason or this is the way how the data marts are getting splitted from the data warehouses. Okay. Okay. Now this is very much important concept, fact and dimension. In data warehouses or in data marts, when we are storing the data in meaningful way, the data can be stored either in fact table or the data can be stored in dimension table. Maybe I have used this kind of terminologies earlier as well. Maybe first day or second day when we were learning the The basic of SQL that time I have mentioned what is fact, what is dimension. But here the details are, I'll be quickly mentioning once more time so that the things should be clear. So as I mentioned, when we are storing the tables in data mart or data warehouses, either that can be fact or that can be dimension. So what are facts? So whatever data we are receiving, if the data is quantifiable in nature, or we can question on top of that how much or how many, whatever answers I'll be receiving, those are nothing but fact data. In the next slide, I have the examples, just like facts are also called measures. Revenue, how much the revenue is, what is the cost, how many number of accounts are there for a particular user. So those are all quantifiable data. Those are called fact related information. It's called facts or measures, anything you can say. And all those facts and measures are getting stored in particular table. Those tables are called fact table. Okay. So here I have put two examples. One is called sales, another one is called billing. In the sales table or billing table, any table you can see the red color highlighted columns. Those are table. I mean, this is sales is a table. In the table, those are column names. Okay, billing is a table. Those are column names. The red color highlighted columns are, you can see, those are quantifiable fact information. Sorry. Yes. So sales, quantity sold, price, discounts, those are measures or facts. Those are quantifiable in nature. Apart from that, in a fact table, you can see some black color columns are also present over here. Same thing over here as well. In billing table, you can see the black color columns are present as well as red. Red things are nothing but fact. So what are the black columns? Black columns are nothing but the foreign keys of different dimensions. Okay. So those are foreign keys. All of these things are keys. Date key, store key, product key. But those are different foreign keys because those particular key can be a primary key from another table. Okay. So those things are called foreign key. What is foreign key? Already learned it. Later I'll be also checking. I'll be checking now the dimension table. You can see each of the keys are primary key from the dimension point of view. So dimension, what are dimensions? If we questions on top of the data, who, what, when, where, generally it should be non-quantifiable. Generally, but there are some scenarios are there. Dimensions can also be quantifiable. So customers, geography, employee, time, all those things in data, generally those are called dimensions. All the store related information, all of the branch related information, customers are already there, employees of the particular industries. So those are nothing but dimensions. So I have put two dimensions over here. One is called store dimension, another one is called product dimension. So you can see the store dimension. All the store related informations are there. And this is the primary key of the store table, store key. The other thing, store name, street address, city, state, region, country. Product table, product key is there. This is the primary key. Product ID, product name, product group, brand, department, those are there. One more important concept, the dimension tables are storing all the dimensions, but you can see the particular data inside the tables should be very less than that of the fact table. Fact table are storing the transactional level information. The billing, what are the billings? Billings can be, I mean, there should be lots of billings in a shopping mall. Maybe uh, within 5 minutes, we can see 2 to 3 invoices are generated. So the fact tables data should be very huge. the data refresh frequency should be very high for fact table. But for the dimension table, you can see today I have 25 stores along with in my particular countries. For a particular country, I have 25 stores in different states. Okay. Maybe tomorrow I didn't introduce a new store. Maybe in an entire 1 year, I haven't introduced a new store. So in the particular store table, the data is kindly a bit fixed. It's not changing daily basis, hourly basis. Similar for the product table. In my particular store, I'm not going to introduce new product daily basis. Okay. As per the column, you can see product key, product ID, product name, product group, product brand, department. So I'm not going to introduce a new product daily basis. So maybe for 1 month, there is no change for the product table. Maybe after 1 month, I can see a new product has been launched and that particular product is very much popular. And the marketing is also good for that product. So I can introduce a new product in my shopping mall and a new row should be introduced for that particular new product. Okay. So that is why the dimension tables volumes are very less comparing to fact table because fact data are very much transactional data. Daily basis transactions are getting stored in, especially in fact table. And one more important thing I just mentioned, there are lots of foreign keys are getting stored in fact table. And you can see those are the primary key in the dimension table, just like store key is the primary key in the store table, which is the foreign key in the fact table, it's the primary key in the dimension table. Similarly, for product key is the primary key in the product table, which is the dimension, and similar kind of product key you can see in the fact table as a foreign key. Why we are storing this kind of foreign key over there? We will be learning those stuffs in our data modeling. Maybe tomorrow's session we will be learning what is data modeling. There we can see why we are putting foreign keys in those fact table. Okay. So I think there is nothing for today. So tomorrow we'll be learning. We just now learned what is fact, what is dimension. Tomorrow we'll be learning how we can combine fact and dimensions and how we can create the data models and why those things are helpful. Okay. So those are the things just we learned. Any doubts so far from anyone regarding fact, dimensions, any concepts on top of BI? Anything, any doubt? Nothing? Okay, good. So let's connect tomorrow with having some more insights on top of fact and dimension table, how the data is getting stored there, and what are the different business aspects from fact and dimensions, and the data modeling, of course, it's very important. Okay, then. Thanks, everyone. Bye. Let's connect tomorrow.